so that other people can view it later. Okay, so why do we? So what is the difference quotient? So we have a difference quotient, z, which is equal to f of, let's say, a plus h minus f of a divided by h. Okay, what is this graphically? So let's say you have a function, right? Like this. Pick some value a. Let's say here. Pick some length h. Right, then this would be a plus h. And when we connect these points, right, the slope over here would be, so if this is y equals f of x, the slope over here would be f of a plus h minus f of a divided by h. Do people believe that? Is that okay? Okay, cool. Yeah, no, Juna, your face is very useful, you know, because your thumbs up is really helpful. All right. Okay. All right. Yeah, maybe. You know what I can do? Let's let's use that, because all of you know how to do actions, right? So you all know, like, because so there's like these reactions, right? And you can just go like this, like thumbs up like that. Okay, so if you know well, okay. Anyway, they disappear after a little bit, right? Okay. All right. So yeah. Okay. So we're good. Okay, guys. Yeah, that's true. There's a lot of stuff. So okay. So this is clear. This is the slope. Okay. Now what I'm going to do is I'm going to think. So this really has a meaning. This is just the slope of the function, right? F, right, between the points a and a plus h, right? Between x is equal to a and x is equal to a plus h. Okay, so that makes sense. Now, why do we care? Well, let me see if I still have this. Right, so this is from before. This is from calc. All right. Let's see. This might be it. Okay. All right. So let's say you have some function. So here is the function. Okay, so I'm going to turn everything off. Okay. So this over here is some function. F of x equals to x cubed minus 5x squared plus 2. Okay. All right. So now I'm going to select this point P. Right. So it has coordinates a comma f of a. This is some random point P on this curve. And here's another random point Q on this curve. Right. And as I vary B, Q is going to move around and P is going to move around. Right. We're okay with that? All right. Okay. So now what I'm going to do is, let me zoom out a little bit. I'm going to, let's say, maybe put P over here. Right. And let's say put Q, I don't know, let's say over here. Right. Now, what would be the equation of the line, right, through points P and Q? So first, I'm going to find the slope. You see this m equals y2 minus y1 over x2 minus x1. You see that part? Well, y2 and y1 are the y coordinates of points P and Q, and x2 and x1 are the x coordinates. Okay, you guys see that over here? Right. So now I define the slope, right? So this is the slope of the line PQ. And now I use the point slope equation of the line, and here it is. Here's the line PQ. Is this okay with everyone? Okay, so I just drew a line PQ. Okay, who cares? But now notice what's going to happen if I start moving Q towards P. So as Q moves closer and closer to P, I get a bunch of these lines. But eventually, if Q is really close to P, like this, I get something that looks like a tangent line to the curve. Okay? So if you zoom in, that's not what I wanted to do. If you zoom in, right, you see at point P, this line is almost indistinguishable from the curve. Okay? So this line actually is almost tangent, right? It's not exactly because Q is not exactly at P, right? But if Q were to get really, really close to P, this line would get closer and closer to being tangent. Does this make sense to people? Yes? All right, so what we're going to say is the following. We're going to have a definition. So I'm giving you like a nice little preview of calculus. Okay? So definition. The limit as h approaches 0 of f of a plus h minus f of a divided by h is the slope of y equals f of x. Well, let's say f of x. X equals a. Okay? So I'm going to say that this is the slope of the graph. Okay? For example, here, if I were to let this point travel in this direction, eventually I'll get the slope, which is roughly like this. Okay? So this would be the limit. Okay? This is what I mean by lim. Okay? Lim is short for limit. Okay? So as this value h approaches the value of 0, this expression is going to, so for example, if h is not exactly 0, but if h is really, really small, you'll get a slope of this line. And as h gets closer and closer to this point, eventually you're getting really, really close to the slope of this line, which you define as the slope of your curve. Okay? I mean, like, who really cares, right? Why? Why do we do this? Okay, I mean, why does this, right? Well, let me ask you the following question. Okay? Question number 1. Okay, and anyone can answer. What is average velocity? Or average speed? Not average velocity. How do you calculate average velocity?
d divided by t.
Yeah, but what do they represent? What is d? What is t? Displacement over time. Okay, but what displacement? Like, could you? So that's how I would write it. This is change in position. Let's just change in time. You could also write this as this, where S, I use S for position. Is that okay? This is your average velocity. Now imagine that you are shortening the interval. Okay? So what if delta t is getting smaller and smaller? Okay, so first of all, what does this represent? What is this really? If you have a graph, let me again draw my favorite graph. This is y equals s of t, right? If I pick some 2 points, right? Let's say this is going to be t1, and let's say this is going to be here t2. If I were to connect, right? So this over here would be s1 comma, sorry, t1 comma s of t1, and this over here would be t2 comma s of t2, right? Then the slope of this line, m, would be the average velocity. Make sense? Very good, right? All right, so notice the similarity here. Here we have the slope between 2 points is the average velocity. Here, well, here this is just the slope, right? Now notice that if I let this point travel in this direction, right, eventually my slope is going to get closer and closer to the tangent line. Okay, so as delta t approaches 0, right, m approaches the instantaneous velocity. Which actually, you probably don't realize it, but yeah, a little bold, okay. So also need to spell velocity correctly. Okay, so this is actually the what you use for velocity or for speed. Like, you know, when you're in a car, right, and you look at the speedometer, for all intents and purposes, what your speedometer is showing is your speed, not your average speed, but your instantaneous speed, how fast you're moving at that moment. Okay, and that's actually what the instantaneous velocity. So there's actually meaning to the slope of the tangent graph. So if you have calculated the slope of the tangent, slope of the graph of the position function, you actually get instantaneous velocity. Do people see that? Right? And this applies to almost like not just to this, it applies to a ton of different things. Okay? So I don't know, let's say you have so let's take any example. Okay? So let's say you have example. Let's say V of T is the volume of water inside a tank. Okay, so let's say you have some sort of, I don't know, situation, whatever. Yeah, so where you have a tank, right? It's going to be time, it's going to be volume, right? And let's say it's being filled with water, okay? Now let's make it more interesting. Let's make it a little bit more curvy. Okay, so let's say the tank is being filled with water. The slope of this graph, like if you were to draw a tangent line, right? So at this point, slope would be equal to the rate at which the tank is being filled. Why? Well, what are the units of this slope, right? If this is the volume, I don't know, like what would the volume be in, I don't know, gallons. Let's say, I'm going to use physics here. So let's say it's gallons. And T, let's say it's going to be minutes, right? Then M, the dimensions of M would be gallons per minute, right? It's going to be something in gallons per minute. Okay, which means that M represents the change in volume per unit of time. So it's the rate at which the tank is being either filled or emptied. Okay, so this is a relationship between the graphs and the slopes of those graphs. Okay, so the slope of a graph is the rate of change. So like whenever you have, so this is like a mini intro to related rates problems, which you will do in calculus. So yeah. Okay. How are we doing on time? So that was me killing 20 minutes. All right. So hopefully more people showed up. Okay, so as more people showed up, do we have more questions about the actual material? Are there any questions about the actual material? Like from class? From anyone? No. Well, you know, I'm just so good, you know, people don't have any questions. Or maybe they're just so lost they don't even know what to ask. Okay. All right. Okay, do we have any questions about what I just talked about now? No, right? I mean, this is like, I don't really want to go like much deeper into this because I'll just end up teaching you calculus, you know, and that's, I mean, there's nothing wrong with teaching you calculus, but I just, you know, a little bit of knowledge could be very, very dangerous. I don't know. But anyway, this is like a really nice preview. I think when you see it for the second time in the future, things are going to be a lot easier for you. All right, okay, let's see what else we got. All right, okay, I guess I'm gonna say it. I mean, I'm gonna explain it in class again, so you're gonna have to hear it for the second time. but I think hearing it for the second time is always better than hearing it for the first time. So let's say I give you some random function. Let's say f of x is equal to, I don't know, let's say 3x cubed minus 7x plus 1 over squared. Well, I don't know, let's say some nonsense like this. Okay, so let's say I gave you this equation. Okay, so who can tell me what is the domain of this function? Now that should not be too hard. Oh, Sydney just asked me about the domain thingy. Okay, well, yeah, that's right. So it's the domain, these are all values of x such that x is bigger than -1, right? Because you have a denominator here, right? And so, yeah, so the following thing has to happen, right? X has to be not equal to or -1. So what do we have here? We have two things. Number one is x cannot be equal to -1 because then you're dividing by 0. And the second thing, x has to be bigger than or equal to -1 because then you're going to be taking the square root of a negative number. Okay, when you combine them together, you just end up with x is bigger than or equal to strictly bigger than -1. Now, if you were to write it in interval notation, you're just going to get this. Is that okay? All right, cool. All right. Now let's do another one. Let's say g of x is equal to okay, hopefully people can figure out this one. By the way, anyone? No? No one's confident? All positive numbers? I'm sorry, guys. So here, x has to be bigger than or equal to 1. Here, x has to be equal to bigger than or equal to -1, right? So when you combine those two restrictions, you end up with x is bigger than or equal to 1. Okay. X cannot be less than 1 because then you're going to be taking square root of a negative number. Sorry, Ashley. Are we okay with this? Okay, let's try another one. Okay, anyone? Now people are just afraid of saying something wrong. Okay. All right, so we have two things, okay? We have a denominator and we have a square root, right? So here we have a denominator, which is x plus 1 squared, which cannot be equal to 0. So x has to be not equal to -1. And here, x has to be bigger than exactly equal to -2. So when you combine those two restrictions together, you get the domain where we go from -2 to infinity. But then you stop at -1 to exclude the -1, and then you go all the way to infinity. If you want to think about it graphically, you go from -2 to -1, you exclude -1, then you include everything else. Is that okay? Excellent. Okay, let's do one more. Okay. So let's do this one. Well, Terry, that's a good idea, but I don't know. No, Sydney, definitely not. I mean, look, they're like square roots and fractions. No, no way. So let's be organized about it. Let's first look at denominators. You just look at denominators, you have x minus 7 is not equal to 0, which means that x is not equal to 7. Okay, that's one thing you got. Number 2, even roots. Have x plus 11 has to be bigger than or equal to 0, which means that x has to be bigger than or equal to negative 11, right? You also have x plus 3 has to be bigger than or equal to 0, which means that x is bigger than or equal to negative 3. Okay? So now we need to combine these three conditions. So x is bigger than or equal to negative 11, and x is bigger than or equal to negative 3, and x is not equal to 7. Well, if x is bigger than or equal to negative 3, it's definitely bigger than or equal to negative 11, right? So we actually can just forget about this condition. Because essentially, what does this say? Like we have, you can imagine you have a set. So these are your real numbers, right? So first of all, we have negative 11. So I'm going to use different colors. Okay. So let's say, yeah, let's use orange. for the first set, for this set. So this is the set of all the numbers which satisfy x bigger than or equal to -11. And then also must satisfy x is bigger than or equal to -3. Also these numbers, right? So therefore you have to select the set with both pink and orange. And now you also have this set, which is x is not equal to 7, so you just have to exclude 7. Okay, so the answer is actually going to be everything from -3 to 7, and then you exclude 7, then you include everything else. That makes sense? Are we all okay? All right, okay, so let's do one more. What about if you have, I don't know, let's say k of x is equal to square root of, let's do something fun. Yeah, what happened to -11? Well, you see, actually, if x has to be bigger than or equal to -3, this -11 really does not matter. You know, like it's like if I gave you a life sentence in prison, then I said, oh yeah, you also need to serve extra 2 years. It really doesn't matter, right? That makes sense, Ashley? So just like if you satisfy this inequality, right? I mean, maybe it's not the best analogy, but if you satisfy this inequality is automatically satisfied. So this inequality is superfluous. Like if I told you x is bigger than 3, or I told you and x is bigger than 12. Well, if x is bigger than 3, sorry, bigger than 12, x is definitely bigger than 3, right? So you could just select this condition, right, and forget about this one. Because but both of these conditions are equivalent to just having this condition. That makes sense, Ashley? Okay, cool. So let's say k of x is equal to, let's say, square root of 3x plus 5. Let's say minus square root of 2 minus 3x. Let's say. So what is the domain of this? This one might be a little bit trickier. Sure. I think your answer will have to involve a fraction. All right. So, any ideas, kids? Janae, what's up?
It's not, x is not equal to negative 5 over 3, and x is not equal to negative 2 over 3.
No. These are not fractions, these are radicals, right? So we have 3x plus 5 has to be bigger than or equal to 0, and 2 minus 3x has to be bigger than or equal to 0, right? Is that okay, Janae? All right. Okay, so this means that we have 3x is bigger than or equal to negative 5 on one hand. On the other hand, we have 2 is less than or equal to negative 3x. Sorry, not negative, sorry, positive. That's new math, I know. Okay, all right. Is this okay? So now I'm going to rewrite it to get x is bigger than or equal to negative 5 over 3, but also x is going to be less than or equal to 2 over 3. I'm going to rearrange this to make this a little bit easier on your eyes. So x is bigger than or equal to 5/3, and x is also less than or equal to 2/3. So I think that's pretty straightforward. That means that it's from minus 5/3 to 2/3, like that. We good? All right, excellent. Okay, so let's try another one. I'm gonna run out of letters. No, let's give you some fractions. Okay. All right, so let's figure out what this is. All right. Now still working? Okay. All right, guys, thumbs up me when you're done or something. Oh, you have to go to another Zoom call. Yikes. All right, yeah, go for it. I'm not holding you. Okay. I mean, the recording will be posted so you can like see how it ends. I mean, we're gonna be done soon anyway. Okay. All right. Okay. See you guys. All right. Okay. We're losing some people. That's okay. Some of us are still here. Wow, this is horrible. Like people are doing back-to-back calls. This is not healthy. This is very unhealthy. This is, yeah, no, I don't want to keep you more than an hour. This is not good. You've already had like so much screen time. Okay. All right, so yeah. So for the first one, right, we get 3x plus 1 has to be bigger than or equal to 0. And here we have 4 minus 6x also has to be bigger than or equal to 0. Combining, we get 3x is bigger than or equal to negative 1. 4 is bigger than or equal to 6x. Putting it all together, we get x is bigger than or equal to negative a third. And here we get x is less than or equal to 2/3. Combining gets, well, not that we need this. We have minus 1/3 less than or equal to x less than or equal to 2/3. Or, oh wait, I'm being a liar. We cannot have an equal sign because we have a denominator. Let's just erase something extra. All right. So the answer is going to be from minus 1/3 to 2/3. Okay, good. So yeah, you can't have a bracket because this is a denominator. So x, I actually cannot have 0 in the denominator. But other than that, I think Sydney, you're right. Okay. All right. We good? All right, kids. All right. So it's been almost an hour. So I think I'm gonna post this and I'm gonna let you guys go. But yeah, let's discuss this tomorrow because I think if we want to have review, I don't know. I did not particularly enjoy this, to be honest, because I feel like you guys just jumped ahead of everyone else. So when I guess when I teach it in class, it's going to be a lot easier for you guys. I mean, if you're okay with that, if you're okay with like just learning stuff in advance, I guess that's okay. But I feel like the people who are in this in here are, many of you are, doing well anyway. But if you're okay with doing this, that's fine. But I know I would prefer people who have questions to show up and ask questions, to be honest. But anyway,
Mr. Sklar?
yeah,
So could you say for the last question for each term you can like find a what do you call it again? A principal or whatever you call it? I forgot what it's called.
principal root. I'm not sure. Interval. I don't
What's in the what's in the brackets, I believe.
know. Okay. So what I can do is the following. You have 1 over square root of 3x plus 1. And you can say, all right, so this guy, if I look at what x could be, right? X has to be at least minus 1/3 for this to be true. For the second one, 2 over square root of 4 minus 6x. X has to be at most 2/3. Because if x is bigger than 2/3, we're going to have a problem. All right. Okay, we're going to have a negative denominator. Now what you do is you take these and you combine them together. Okay? And whatever their new overlap is, so when you combine them like this, right, you get integral from -3 to 2/3. That makes sense? Yes, that's essentially what we're doing.
Yeah,
You
I
can just-
kind of. I'm just asking, like, for each term, could you put that as a? I lost the word, but I'm trying to remember what it was.
Okay. Well, I am not sure what you mean by that. Can you like describe it in some way?
Like, what's in the brackets? Like 3x plus 1 is greater than 0.
It's a radicand. Radicand.
No, I'm talking about in the brackets below.
In the brackets? There are no brackets. You mean parentheses?
Or is that braces?
These are parentheses. Oh, this guy?
Yeah.
Oh, these are like, yeah, brace. Yeah, sure. Yeah. Well, it's not really about in the brace. This is sort of a symbol, which means it unifies these two statements. It says that both of them have to be true simultaneously.
I know, I was
And
trying to
this
say, for each term, would there be one? For each term. I'm saying for each bracket, would there be like one inequality? Sorry, oh my god. I mean, one term, one inequality.
Well, yeah. So for each guy, there's this inequality. For this guy, there's this inequality. Yeah. So yeah, for each term, yeah, for each like radical or fraction, there's usually one inequality.
Okay, thank you.
Yeah. I mean, unless of course it's something more complicated. Like if you have something like this, let's say square root of x squared plus 3x plus 2, right? You have to factor it first, right? And from there, you get x is going to be either bigger than -1 or x is less than -2. Okay, but I think, no, yeah. So, but that's yeah, that's a little bit more advanced, and I think I'm not sure we're really going to get there. Okay. All right, guys. All right, so let's call this it, and yeah, maybe I'll see you next week, right? Well, I'll see you tomorrow for sure. All right. Okay. All right. Okay. All right. Okay. I'll see you guys. Yep. See ya.